As per Newton's third law of motion, if an object 1 exerts a force on object 2, then object 2 exerts an equal and opposite force on object 1. Forces exist in pair. Every action has equal and opposite reaction force and works on different objects at the same time. But not every pair of forces are Newton's action-reaction pair. Check these out. Number 1. A block is resting on a table. The force of gravity works as weight of the block in downward direction, while an equal and opposite normal reaction force by the table works on the block in upward direction. Is this pair of normal force and weight of the block can be considered as a Newton's action and reaction force pair. Number 2. A block is hanging with a massless rope. The force of gravity works as weight of the block in downward direction, while an equal and opposite rope tension force works on the block in upward direction. What do you think about this pair of forces? Number 3. A block is attached to a spring and pulled by a horizontal force F in positive x direction, while an equal and opposite spring force works on the block in negative x direction. Is this pair of force F and spring force can be considered as Newton's action and reaction force pair? To answer these, ask following questions to yourself. 1. Are the forces in consideration generated because of interaction between two objects? What are those two objects? Number 2. Are the forces equal and opposite in direction and work on different objects? And number 3. Are the forces of same nature? Same nature means like gravitational force, spring force, normal force, etc. If answers to any of the above question is no, then that pair is not the Newton's action-reaction force pair. Now, before going back to these examples, let's check out few more cases. Case A. In a rocket launch, the rocket lift force is equal and opposite to the combustion exhaust force. Do you think these forces makes Newton's third law force pair? Case B. A bird flies upward because of downward force on air by its wings. Can these equal and opposite forces be considered as Newton's pair of forces? Case C. What about equal and opposite forces during rowing of a boat? Are these forces makes Newton's action-reaction pairs? Yes. In all the above three cases just discussed, forces are related to interaction of two objects, rocket vehicle and exhaust, bird and air, water and boat, equal and opposite direction and are of similar nature. So those are Newton's third law pair of action-reaction forces. Now, what about our first three examples? Are forces in each of those examples are Newton's action-reaction force pairs? No. Although in each of those examples, forces in considerations are equal and opposite, but they are working on same object, block, and not on the different objects. That's why they are not Newton's third law action-reaction pairs. Now, as per Newton's third law of motion, since interaction forces exist in pair, then in our first three examples, where are the missing forces of Newton's force pairs? Example 1. There are two forces, weight of the block and the normal force. Weight of the block is gravity pull by the earth on the block toward its center. And by the same force, block pulls the earth in exactly opposite direction. Both of these forces are gravitational force in nature and make Newton's third law force pair. Now what about normal force on the block? Table exert a normal force on the block equal and opposite to the block's normal force on the table in downward direction. In this case, normal forces between block and table is same as block's weight. But it may not be the case when objects are in accelerated motion. We will see the effect of acceleration on the normal forces between two objects later in this video. Example 2. Weight of the block is gravity pull by the earth on the block towards its center. And by the same force, block pulls the earth in exactly opposite direction. As we saw in previous case, both of these forces makes Newton's third law of force pair. Another force is upward tension force on the block. This is in reaction to the block's pull on the rope because of its weight. Example 3. Block pulled by a force F exerted someone invisible. As a reaction, block pulls the invisible person by an equal and opposite force F dash. So F and F dash are the Newton's third law force pair. What about the spring force on the block? Block also pulls a spring with the same magnitude but in opposite direction with force F. So F and Fs are the Newton's force pair. Now let's check out the effect of accelerated motion on the action-reaction force pair. In example 1, let's assume table and block are in accelerated elevator, moving in upward direction with acceleration A. So in this case, what are the forces working on the block? Force of the gravity as weight W in downward direction and the normal reaction force N by the table in upward direction. Now the block is moving with acceleration A, same as elevator in upward direction. So as per Newton's second law of motion, the net force is equal to NA. It shows that the normal force on the block increases by force NA. Now at the same time, as per Newton's third law of motion, this normal force N by table on the block is equal and opposite to the normal force NTB on the table by the block. What about the gravity force on the block and its reaction force on the earth by the block? The earth gravity is constant near the surface. So its pull on the object remain constant even the object accelerating in upward or downward direction. And what about the reaction force of the block on the earth? It will also same and remains constant. Check out next part of this video to know how to solve real life problems using Newton's second and third laws. Before closing of this session, can you answer following questions? Put your answers, queries and doubts in comment box and let me know what part of this video you liked the most. I hope you would have enjoyed this session. If you think you have learned something new today, then please click like button and subscribe us for similar type of videos. Thank you for watching. See you next time. Bye.